Suppose you need to solve a trig problem that looks like this. So there's a trig function, it's equal to something, but there's a lot of stuff going on inside the function. These are a little more complicated, but there is a strategy that works every time. You've already isolated the tangent here, tangent of whatever equals 1. Go to your unit circle and find out where that's true. Tangent is going to be equal to 1, where sine and cosine have the same value. If you just think that if these two are the same, then tangent will equal 1. So you go over here and you see it happens here at pi over 4, and we know we need to use radians, or at least we're very suspicious because there's a pi over 4 here, which makes us think radians. So it's going to happen over here at pi over 4, but also down here, I don't have it written in, but this measure here would be 5 pi over 4 for the angle, where they're both negative root 2 over 2. So the negatives cancel out when you divide them. The strategy then is you know that the tangent of whatever equals 1 when the whatever equals pi over 4 or 5 pi over 4. So what you do is you say theta over 2 plus pi over 4 equals pi over 4, because that's what we found out here. But let's also go over here and let's say theta over 2 plus pi over 4 equals 5 pi over 4. From here, it looks like a pretty simple equation. You just subtract pi over 4 from both sides here, then multiply by 2. But it's not quite that simple, because it doesn't just occur, for instance, at pi over 4. It's pi over 4 plus any full rotation away from that. Same with 5 pi over 4, it's any rotation from there. Now with tangent, you could simplify that a bit, but most of the time, that's the strategy that works. Find the two spots and do full rotations from there. So this is plus 2 pi k, or n, or whatever letter you're using for the integer. This also is plus 2 pi k. Now from here, you can do the algebra to solve for theta. At this point, you are almost done. This would be the general solution, but this question did not ask me for the general solution. It asked me to solve in the interval 0 to 2 pi. So what I need to do now is just check and see which of these are going to give me solutions in 0 to 2 pi. I'm not using any negatives for k because all of these need to be positive, and positive values of k are going to give me positive values here. If k is 0, theta is 0. If k is 1, theta equals 4 pi, which is too high. We don't even need to check that one. Similarly here, when k equals 0, we get theta is 2 pi. When k equals 1, we put 1 in, 2 pi plus 4 pi times 1 equals 6 pi. So it looks like these are only two solutions in that interval from 0 to 2 pi. And then you go check those to make sure that I got this right. And I would have gotten it right, but it said strictly less than 2 pi, so this one actually didn't count. So all that work, and I ended up getting it wrong because I wrote the problem down incorrectly.